Hey guys, Werner and the BerryBot here. You guys will probably think I'm totally off my rocker, but I got to thinking about something. I made my first functional part today. It was really cool. It was a little angle bracket, and it turned out pretty cool. Had 125 degrees C on the Platen, and I still ended up, the part was only an 1/8 inch wall and about 3-inch leg on one side and about an 1.5 inch leg on the other side. And I got a little bit of warpage, about maybe a 32nd or 1/16 of an inch, worst case. And so I got to thinking, what if I could create a small chamber for small parts on my Delta machine? So the idea was that to have a plate mounted to the end effector, and then have a more or less a cage or a puck or whatever you want to call it that would move around on the surface of the glass as the end effector moves, basically trapping the heat within that space. Now with this setup I can only do 1.5 inches high, and the diameter I have set, of course you'd be limited quite a bit in the diameter you could do, but I thought, you know what, I'm just going to try it. I'm going to see what the difference is, just for the heck of it. So we'll go ahead and we'll make that same part again. And actually, let me take the camera off. I'll give you a better view. This is the actual part right here in Slicer. And I'm going to be running it on this little machine here. And this is that top plate. Basically what's going to happen is it's going to come down and it's going to get captured in this other plate here. And then what it'll do is it'll just go around, do its thing, make its part. But what it's going to be doing is containing a lot more heat within the print area. So yeah, what the heck? Let's give it a try and see what happens. What's the worst that could happen? I'm going to go ahead and juice the glass here. That's what I call it when I put my mixture of ABS glue and acetone on the Platen. Juicing the glass. So I know my print's usually a little bit over this way. That should be good. Kind of self-levels it. It kind of levels itself out, which is kind of nice. And I just, I'm just starting to preheat the bed. Okay, guys, we're up to temp, and as that was doing that, I ended up making this a little bigger, about 3 inches. So we'll go ahead and run her. I'm just going to give it a little guidance as it's coming down, make sure it centers upright, and then just drop it onto the glass. We'll see what happens. We're getting real close. Kind of takes the fun out of watching it. You don't get to see anything. But we'll see what happens. Should keep it much hotter inside there. So far so good. This is the outer skirt, so if this clears everything, it should be fine for the actual part. Well, there we go. It's going. It's going. Alright, well, this will take a little bit, and then I'll go ahead and I'll speed this thing up for you guys. Well, there we go, guys. I'm going to do a G28, and the first thing I'm going to do is I'm going to measure the part temperature at the very top. We're at 95 degrees C at the very top of this part. So the very top of this little part is 90. It's already starting to cool down. It's 95, cooling down to 84. And you know something? It made a significant difference. Golly. And I'll tell you how I know this. See this right down here? See this corner right here? My special goop was pulled up just a little bit, about a 1/16 of an inch right here. So I can tell already that made a significant difference because it's not pulled up at all. Very, very interesting experiment on that. So you can see, look at the part is up at the very top. It's still at 80 degrees C. So, wow, that's really something, guys. Very interesting. Surface finish looks really good. Not bad at all. So I'll pull the camera down and let you take a quick look-see at it. By the way, the camera turned off partway through the print because I didn't have it plugged in. So I hurried up. I went in and had dinner. Came out here and the camera wasn't going, darn it. Anyways, you get the idea. Yeah, surface finish looks beautiful. And my guess is this thing is going to be very true with almost zero warpage. That is interesting. Very, very interesting. There's the underside of that little thing. Didn't catch fire. That's good. So guys, that's interesting. I'm going to let this thing cool. I'm going to pop it off, and then we'll take some measurements and see how this one compares to the other one. Very good. Hey guys, I got both of the parts that I made, the one we just made together and the one I made earlier. This part was actually in service. I was using this, and I pulled it off just so that we could see what the difference is. I mean, just visually looking at them, when you have them in your hands, it's obvious. There's a significant difference in the one that was in the heated chamber versus the one that wasn't. I'm going to bring the camera over here and let you take a look at what I'm talking about. I have a huge pair of calipers, so these are nice and parallel, so we can put the pieces in there and take a look at them. So we'll do that. So at first glance, they look pretty similar, you know, as far as finish. One thing I did notice, and you can probably see this yourself, is this is the one that was in the heated chamber, and you can see it got a little too hot. I think that the temperature on the end effect on the tip could be decreased from 245 to somewhere maybe around 230, 235. And it would give us more of a finish like the one that wasn't in the heated chamber. Both of them structurally seem to be the same. You would think this one would have a little better bond in between layers, but they seem to be very similar. So what I'm talking about now, this is the one in the heated chamber. So let me grab my big huge caliper here, and we'll put this on here. And I want you to notice that it's absolutely perfect as far as being parallel. See that? That's perfect right there. Very difficult to do with ABS. And this was my first part. Not so perfect. You see over here, right here on this end? See how much of a gap there is? Almost nearly a 1/16 of an inch at the worst places right here. So you can also see over on this very corner here, it lifted just a little tiny bit. That's only about a 32nd of an inch right here. So there's no question in my mind that that's significant in the way it worked. Again, here's the heated chamber part, and I think it would even be better with having the heat reduced. it's obviously was getting too hot, having that airspace heated to somewhere between 80 and 90 degrees C, as well as having the tip temperature what it was. So anyways, yeah, pretty exciting stuff. The cardboard fixture that I used to contain the heat, had another idea about that. Imagine, if you will, this is the center disc, and this is something that's actually 2 layers thick, very thin material. I'm talking about like 20 thousandths aluminum or something of that sort. Very lightweight and very thin. And this would be the one that would mount onto the end effector. Okay, so basically you have your end effector, and maybe you would have 3 little arms, 3 little carbon arms that would be held onto this, no less than with magnets. And then the idea is, with 2 layers of this, it would have a slit in the middle that you would have a ring, something like this. So what it would do is it would allow the end effector more travel without interfering or coming off the end of the edge of the glass. My glass right now is 14 inches in diameter. If I was to oversize my glass and make it like 16 or whatever it is, take it all the way to the belts, I could significantly increase the usable area of having this containment unit. I'm thinking it could actually be like 8 inches in diameter and 8 inches in height, which would really be awesome. Now, the 8 inches in height may be difficult to get in the way of a cylinder, but I think if it was done right and it had a felt pad on the bottom to ride on the glass, I think even when it was up at the 8-inch height dimension, it would move around very nicely, assuming it was all built really lightweight. So yeah, that's really significant, I think, and I don't think it's been done. So anyways, something interesting, something else to work on. Hope you enjoyed it.